Here's a explanation of the Chapter 8 summative practice, just working through some of the problems. So if you have your summative available there. Number 1, we are just changing the form of the problems. We're going from log form to exponential form. So number 1, the base is 2. It'd be 2 to the 4th is equal to 16. Number 2, it's natural log, so your base is e. It would be e to the 3rd is equal to 5y. 1c, there is no base given there. It would be assumed to be base 10, so it would be 10 to the 3rd power is equal to 4x. And then in number 2, in 2a, we're going the other direction, changing to log form. It's base e, so it'd be natural log of 40 is equal to the exponent, which would be 3x. In 2b, we've got log, it's base 3 of 18, and that would equal 2x plus 3. And that's one where you could solve that by simplifying that log. In number 3, evaluating these expressions, 3a you cannot do mentally, so I'd like you to do this by change of base. So it would be log of 300 divided by the log of 4. And that's going to come out to be about 4.1144. B, we can do that mentally. What's the power of 4? That gives you 64, which would be 3. In number 4, we're solving logarithmic equations. 4a has a log, a single log by itself. We can change the form, so it'd be 3 squared is equal to 2x minus 1. 2x minus 1 would equal 9. And then I'm going to add 1 and divide by 2, and I would get x to be 5. In 4b, we are adding 2 logs with the same base, so we're going to combine and multiply those. And if I multiply those, I'm going to FOIL. So I'm going to have x squared plus 2x and minus 3x would be a minus x minus 6. And that's going to equal a log base 3 of 6. And this is our common sense property, so this one's going to equal this. I've got x squared minus x minus 6 equaling 6. Could it equal to 0 because this is a quadratic? Factoring this, I'd have minus 4 and plus 3. So my solutions would be positive 4 and negative 3. Can't take the log of a negative number, and if you put negative 3 in there, that would become a negative number. So the only solution there would be 4. Number 5, using what they give you, we have log base 5 of 18. Could do this several ways. I could break that up into 9 and 2. You could also do 6 and 3 here. And then this is good. 3 could be written as 3 squared, moving that power in front. I now have 2 log base 5 of 3 plus the log base 5 of 2. And then I would just substitute in those decimal values for these 2 logs. Should get an answer of about a 1.7959. Number 6, we're to have division, so we can break this up and subtract. But again, this 4 could be written as 2 squared. Bring that 2 in front. So now it's the log base 5 of 3 minus 2 times the log base 5 of 2. And you should get about a negative 0.1788. Number 6, 6a, we have a logarithmic equation. We want to get that natural log of 2x by itself. So I'm going to add 5 to both sides. I'm then going to divide by 3. And then since I have this by itself, I'm going to change the form, so it'd be e to the 5th is equal to 2x. So taking e to the 5th, dividing by 2, you're going to get x to be about 74.2066. For part B, I'm going to get that e to the x part by itself. So I'm going to add 3. I'm going to divide by 2. Now changing the form, this is log base e, which is ln of 4 is equal to x. So x would be 1.3863. 6c, I just simply change the form. That's 10 to the second power is 4x minus 5. So 4x minus 5 would equal 100. Add 5 and divide by 4, and you're going to get 26.25, which checks. Letter D, if I change the form of this, it's log base 7 of 50 is equal to 3n minus 2. I can do log base 7 of 50 by log of 50 divided by log of 7. And then I'm going to add 2, divide by 3, and you're going to get n to be about 1.3368. Number 7, we're depositing $850. So if I'm compounding this, in this case, they want us to compound it weekly. I would take that 0.034 and divide by 52. There's 52 weeks in a year. Add the 1 because it is growing. My beginning amount is $850. I'd be taking it to whatever 52 times 6 is, would be this power. And if I do that, I should come out to be about $1,042.28. Compounded continuously means infinite number of times. We're going to use PERT, 850 times e to the 0.034 times 6 power. Should be just a little bit more than it was, so 1,042.35. And then the last one, we want to know when will it be worth $20,000. So $20,000 is going to equal 850 times e to the 0.034, and we don't know the time, so that is our t. We're going to divide by 850. And you're going to have e to the 0.034 t power is equal to whatever 20,000 divided by 850 is. And then, and that is about 23.5. So then you're going to change the form of it. So it'd be natural log of 23.5 would equal 0.034t. We're going to take the natural log of 23.5 and divide by 0.034. We're going to get t to be about 92.9 years. Number 8, bear with me here without a graph. We've got 2 times 3 to the x plus 4 minus 1. So I'm going to focus on this as my parent function. That graph will have a y-intercept of 2. And as I go over 1, I'm going to multiply by 3. So I'd have the 0.16. If I divide by 3, I'd have 2/3. And then I'm going to move left 4 and down 1. Left 4 and down 1. Left 4 and down 1. The graph's going to look like this. It's going to get closer and closer to -1. Domain would be all reals. Y is greater than -1. And then in B, we've got a logarithmic graph. It's base 3. So I'm going to focus on graphing this part of it first. I'd have the points 1, 0, 3, 1, 1/3, -1. And then I'm going to make my movement. So I'm going to add 2. I'm going to go right 2. I'm going to multiply that by 3, which puts me up at 3. And I'm going to go up 1. this point, I'd move right 2. If I take 3 times 0, it's still 0, and then go up 1. And for the 1/3 negative 1, I'm going to go right 2. Multiplying that by 3 gives me negative 3, and I'm going to go up 1. This graph's going to look like this. And it's going to get closer and closer to 2. Domain here would be x is greater than 2, and my range would be all reals. So I hope this helps you in your reviewing for the Chapter 8 summative, which is tomorrow. It's going a little bit fast, but you can always review or rewind and keep watching it several times.